In this video, we'll be talking about alkanes, what are they, systematically naming alkanes, and then identifying isomers of alkanes, and we'll define what those terms mean. So first let's talk about what an alkane is. An alkane is going to be any molecule that contains only carbon and hydrogen atoms. The first example that we have here is called ethane, right here. Notice that ethane only contains carbon and hydrogen bonds. In future chapters we'll talk about compounds that contain double and triple bonds and also aromatic rings. But for now, this chapter will just focus on compounds with single bonds. All these alkanes are also known as hydrocarbons, which is a term that you've probably heard before. And we're going to start off talking about how to name alkanes, and the easiest way to start is with the simplest alkanes, which are linear alkanes, or also known as straight chain alkanes. I'd like you to learn the names of the first 10 alkanes: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Now the first four I think are the most difficult to learn: methane, ethane, propane, and butane. The rest have a prefix that you're already familiar with. So there's a simple mnemonic that you can use in order to remember these, which is me eat peanut butter, methane, ethane, propane, butane. Methane is CH4, so it has one carbon. Ethane would be CH3 bonded to another CH3. It has two carbons. Then propane would be 3, butane would be 4, pentane 5, hexane 6, heptane 7, octane 8, etc. So first thing that you want to do is, if you see a name, you want to be able to draw the structure, or if you see the structure, you want to be able to draw the name. These 10 are relatively straightforward, but we're going to use these names to name pretty much all other more complicated alkanes, which we'll talk about here in a second. The other kind of alkanes that we're going to worry about naming are alkanes that are in rings. We've seen some examples of these in class. We're going to name these pretty much exactly the same as we named linear alkanes, but we're just going to add a prefix cyclo at the beginning. So if you have 1, 2, 3 carbons, that would be cyclopropane. If you have 4 carbons, cyclobutane. If you have 5 carbons, cyclopentane. So for example, if we drew a 6 carbon ring, that would be cyclohexane, and that's really as far as we're going to go in this class. So it obviously gets more complicated than that, and what you'll find is that once you get above 3 carbons, we have the possibility of isomers. An isomer, in this case constitutional isomer, is going to be a compound that has the same formula, or two compounds that have the same formula, but the atoms are connected in a different order. For example, if you have a formula of C4H10, you can have those 4 compounds arranged in a chain or a line, as we do in just regular butane. But notice we can also have 3 carbons in a chain with 1 branching off the middle, and we'll learn how to name those in a second. As you get more and more carbons, you have the possibility of several more isomers. So for example, for pentane, we could have 5 carbons in a line, which would be named pentane, or you could have 4 carbons in a line with 1 branching off, or you could have 3 carbons in a line with 2 carbons branching off the middle carbon. Okay, so how do we name these substituted alkanes? Substituted alkanes will be different than linear alkanes because you see they have things branching off of a long chain. So the first thing that we're going to do is find the longest chain. So notice that there's several chains here that we could count. We could count 1, 2, 3, 4. We could count 1, 2, 3, 4, 5. But notice the longest chain is 1, 2, 3, 4, 5, 6. So the longest chain in this particular case is hexane. So that's going to be the base name. Hexane is going to be the base name because that's the longest chain of this alkane. Now what we're going to do is name all the substituents as alkyl groups. A substituent is a thing that's branching off. Since this is one carbon, instead of a one carbon alkane is called methane, so the substituent is going to be named as an alkyl group, so we drop the ane and we call this methyl. Notice that instead of ane we added yl to the prefix. Methane is now methyl. So we're going to call this methyl hexane. But we want to specify where the methyl group is, so you want to number the chain, giving the substituents the lowest numbers. If we start here, this could be carbon 1, 2, 3, 4, 5, and 6. And so we're going to call this 3-methyl hexane. The 3 tells us where the methyl group is. It's on the third carbon. Notice if we started here, the methyl would be on carbon 1, 2, 3, 4. So we want to choose the direction that we name the alkyl group by starting in a spot which will give us substituents in the lowest position. So 3-methyl instead of 4-methyl. Let's do another example. Okay, first find the longest chain. That's going to be 1, 2, 3, 4, 5, 6, 7. So this compound is going to be named as a heptane. And then these are both methyl groups. So we have 2 methyls on this carbon, so this is going to be called a dimethyl heptane. And notice that both methyls are on the second carbon. 1, 2, 3, 4, 5, 6, 7. Notice if we started numbering here, it'd be 1, 2, 3, 4, 5, 6. So we want to start here. That gives our methyls the lowest priority. And we list both numbers to specify that both methyls are on the second carbon. So we call this 2, 2 dimethyl heptane. Notice that numbers are always separated by a comma, whereas numbers and letters are always going to be separated by a dash. You want to remember to do that when we're naming compounds. Okay, the last example contains a ring. So what we're going to do is treat rings and chains differently. The chain has 1, 2, 3, 4 carbons in it, but the ring has 6. So the base name is going to be whichever one is bigger. So the base name in this case is going to be cyclohexane. And we have a butyl chain. This would be butane, but since it's an alkyl chain, branching off of our main group, we call this butyl cyclohexane. We don't have to specify the position of the butyl group. There's only one butyl group, so if it was here or here or here or here or here, it would still be butyl cyclohexane. If we have 2 or more groups, we'll talk about how to name those in a future video. So this would just be called butyl cyclohexane. We can also have branched substituents, so notice that this is a butyl group which has a carbon branching off. So we have a branch on our main chain, which is this entire group. But this group has another branch on it. I'm not going to be too worried about requiring you to learn the rules for naming these complex substituents, but you should be aware that they exist. So the rules are exactly the same as how we name compounds, right? This is a butyl group, and we have a methyl group branching off the 2, so we call this 2-methyl butyl, and then that whole group goes in parentheses, which is branching off the main chain. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We didn't even learn how to name 11-membered compounds, but that's called undecane. And this is at the 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 6-2-methyl-butyl undecane. Again, probably not going to have any examples of these. So if we're going to just look at naming complex substituents, right, we're going to look at these two. Again, what you want to do is find the longest chain of the substituent itself, which is 1, 2. So this is an ethyl group. And we have a methyl group branching off on the first carbon, so there's a 1-methyl ethyl group. which is on a 1, 2, 3, 4, 5, 6, 7 heptane. Let me rewrite that here. A 1-methyl ethyl group. Here again we have the longest chain is 2 carbons, and we have 2 methyls branching off. So we're going to call this a 1, 1 dash dimethyl ethyl group. What's much more common are the common names that are used to name these substituents. So if we have a long chain with this thing branching off, we call that a propyl. If it's substituted at this carbon, we call the IUPAC name, or the systematic name for this would be 1-methyl ethyl, but much more often we just call this an isopropyl. It's an isomer of a propyl chain, so we call this an isopropyl group. For 4 carbons, there's 3 possibilities that I'd like you to know. You can have sec-butyl because it's substituted at a secondary carbon, isobutyl, or tert-butyl. So learn those 4 common names for the 1 for propyl, isopropyl, and then the 3 butyl ones. Those are going to be used much more commonly. Okay, so let's look at the examples that we just used earlier. Before we call this a 1-methyl ethyl group, now we're going to call it an isopropyl group. If we use common nomenclature, it's on a 7-carbon chain, so we'll call this compound isopropyl heptane, and the group is on the 3rd carbon. So this is 3-isopropyl heptane. We do it for the one below here. We have this substituted substituent, which we previously called 1,1-dimethyl ethyl, which is a mouthful, so now we're going to call this tert butyl. It's on a 1, 2, 3, 4, 5, 6, 7, 8. So this is tert butyl octane. And our group is on the 4th carbon. This is 4 tert butyl octane. Okay, so you need to know how to name simple organic compounds called alkanes. They can be linear or substituted. Learn the first 10 linear alkane names. Those are going to be our base names. Learn how to name cycloalkanes, and then remember these rules for naming substituted alkanes. First, you name the longest chain. You name all the attached groups as alkyl groups. Number the chain, giving all groups the lowest possible numbers. And then be careful when we're looking for the longest chain. We'll do some examples of these in class.